Okay, so good morning to everyone. Good afternoon to some, and here, particularly in the Philippines, good evening to everyone. So, greetings in general. I welcome you again to this seventh Online Vedic Mathematics Conference, and I am here. I will be presenting my research article in General Case Integer Subtraction. By the way, I am Sharde Alova. You can call me Shard. I am a life member of IAVM, Institute of for the Advancement of Vedic Mathematics, and I am currently a faculty in the Mathematics Department of the College of Arts and Sciences here in the University of St. Lasal in Bacolod in the Philippines. I have taken a couple of courses also under Vedic Mathematics Academy through Mathenic Philippines. I am an advocate of Vedic maths, and I have been sharing Vedic maths here in my region in the Philippines in a couple of webinars and seminars, that is during pre-COVID, and I currently do research in the field. And I am very much excited to share the results of one of my papers, which is General Case Integer Subtraction. So let's get into it. Let's have first the overview of this presentation that I will give. First, I will give you the introduction, some recaps, recalls that we need to do before we go to the actual paper itself. Then we're going to deal with the general case arithmetic subtraction. This is actually known already. I saw this technique in some courses of from the Vedic Maths Academy of Sir Ken's. And I just named them general case arithmetic subtraction for the purpose that it will go and be developed into general case integer subtraction. Okay, and why it is called that way, we'll see that in the end or by the end of of the the presentation. Of course, with every maths paper, we need to provide a proof of how this happened, why is this true, and I will be giving that to you by the end. And then, of course, I'm going to give the summary and the conclusion. After which, I'm going to, of course, give you the references of this paper that I have. So let's get into it, and then let's start with the introduction. Okay. So I see my paper as the simplest here in the conference, but I see it as of high importance as far as my field of work is concerned. That is in education, particularly in mathematics education. And it can also aid in pedagogy, especially looking at our pupils and our students. They're struggling with mathematics. Well, not all, but the common perception for math is that it's difficult, and I believe we won't say no to that. And hopefully this paper can aid to that difficulty of pupils or students when it comes to mathematics. So let's start. Vedic maths is a holistic, coherent, and unified system of mathematics. Um, and subtraction, okay, is one of the fundamental operations of math. Okay, and one of which that pupils see as difficult. Okay, but with this paper, with the system of Vedic mathematics, subtraction can now be done with much simpler, easier, and more creative method, which can change the way pupils see subtraction, okay, as a fundamental operation in arithmetic and in also the whole of mathematics itself. Okay. What we're going to do here is we will show the firepower of the sutras, all from 9 and the last from 10, for the general case arithmetic subtraction. And then we're going to add up another sutra that is transpose and apply for our general case integer subtraction. Okay, so let's have our recalls first. So we will have some recalls. We will see how we do subtraction in the conventional way. Some call it the blanket method, how we do this. So again, subtraction is one of the operations that kids see as a tedious routine. Okay, it's a routine that kids, as my students are concerned, they see it as tedious to the next to division, okay, next to the operation division, since it includes borrowing and taking away of numbers to the next digit, and then continue so that you can continue the operation. So let me give you an example of how this is done in the conventional way. So we're going to write 10,000 here. Excuse my penmanship. Minus 3,579. Okay, so how do we do this in the blanket method? We do this from right to left. Okay, we do this from right to left. So we're going to start with the ones digit. So 0 minus 9, we say that cannot it cannot be done. So we're going to borrow a 1 from the next step. And then you can see that the tens digit is also 0. So we're going to borrow 1 from the next place digit. So it's like we're going to cancel this, cancel this, cancel this. And then the hundreds place is 0 also. We're going to borrow to the next place digit, cancel this. And then lastly, for the thousands place, it's still not 1, it's a 0. So we're going to borrow to the 10,000 place. So meaning how we do this is that actually the blanket way of doing this is that this one becomes 0 because it's going to be borrowed from the by the previous place digit. So this 0 will become 10. But we need to borrow this 1 from 10 to make the hundreds 10. So this becomes 9. This hundreds becomes 10. And then we're going to continue the process. Okay, this 10 becomes 9, and this tenths will become 10. And then this tenths digit will become 9, and then this ones digit will become 10. Okay, so that is actually the correct and routine way of us doing subtraction. And how we teach our students subtraction is also like this. Okay, so let's get into it. So 10 minus 9 is 1, 9 minus 7 is 2, 9 minus 5 is 4, and 9 minus 3 is 6. So what we have is 6, 4, 2, 1, 6,421. And that's correct. Okay, that's correct. Now, how do we do this in the Vedic method? Okay, so this is not part of my proofs. This has already been given to a lot of Vedic maths conferences, a lot of articles. So in the Vedic math subtraction, we're going to make use of this sutra. This is Nikalam Navatskaram Dasata. So in English, that's all from 9 and the last from 10. Using the Vedic methods, subtraction can be solved without doing any of the things or any borrowing or taking away of numbers from the previous step. You can see that the previous step is kind of messy. Let's go back and look at that. You can see it there. Okay. Well, it gives us this answer, the correct answer, but it's kind of messy up in the minuend. Okay, we call this a minuend. We call this a subrahend. Okay, and we call this as the difference or the solution. So looking at that, it's kind of sloppy, it's messy, and the Vedic methods don't use that kind of messiness in subtraction. So with generally how we use subtraction with base numbers, when we call base numbers, these numbers are with all the zeros here, and then we have an integer or a whole number in the first digit, okay, in the leftmost part of the digit place digits. So are the again, generally the base numbers are the most difficult. Okay, they're the most difficult for the students because it takes a lot of borrowing, taking away of numbers, and other subtraction methods are done routinely, and they are trivial to write it down here. But I'm going to go directly to the most difficult, which is in routine, conventionally. Now, what we will do here is we're going to understand that all the digits are all from 9, and except the last non-zero digit, which is from 10. Okay, all from 9, and then the last non-zero digit will be from 10. So what we're going to do is we write that again. We have 10,000 minus 3,579. So how do we do that? All from 9 and the last from 10. First condition, all the zeros must be equal to the number of digits we have on the subtrahend. So, and then we can apply the sutra. Okay, so this becomes, what will you add to 3 to make it 9? So that's going to be 6. What will you add to 5 to make it 9? That's going to become 4. What will you add to 7 to become 9? It's going to become 2. And this is the last non-zero digit, so that's 9. So what will you add to 9 to make it 10? Not 9, okay? Last from 10. So this becomes 1. So that's 6,421. Pretty much the same thing from the previous slide, only that much cleaner. It's not messy. It's straight to the point, and we got the answer right away. Okay, I will refer you to the references later for more examples, okay, so that you can do more examples out of this. Okay, so let's get into it. One more example. So we have 50,000 minus 3,579. So it's still a base number, but look at the first digit on the leftmost part of the place digit numbers here and the minuend. It's 4. So by default, we will minus 1 here. That's by default. That's going to become 4. And then apply all from 9 to the last from 10. What will you add to 3 to make it 9? That's 6. What will you add to 5 to make it 9? That's 4. What will you add to 2 to make it 9? That's sorry, 7 to make it 9. That's 2. And what will you add to 9 to make it 10? Since it's the last non-zero digit, that's 1. So that's our answer, 46,421. Okay, and that's how we do the Vedic math subtraction. Again, for more examples, I'll refer to the references later. We also need to recall bar numbers. Okay, we need bar numbers in order for us to arrive to the general case arithmetic subtraction. So convert 59, 38, and 87 to bar numbers. So let's just have a recall here. Bar numbers are, we're getting rid of the big numbers on any of the place digits, and then we're going to convert them into small digits so that the arithmetic and operations will be done easier. So for instance, 59, when we convert it to bar numbers, it becomes 6 bar 1. That is, we take 1 from 60, that's going to give us 59. So that's equal. Only that we got rid of the big number 9. Instead, we replace it with 1. Okay, 38 becomes, what will that be? 4 bar 2. 4 bar 2. Okay, take 2 from 40, that's going to give us 38, still the same thing. And 87 is equal to 9 bar 3. Okay, you take 3 from 90, that's going to give us 87. So 6 bar 1 for 59, 4 bar 2 for 38, and 9 bar 3 for 87. Okay, and then we're going to make use of that example. And we will arrive at the general case arithmetic subtraction. Here, we don't really need to emphasize the base numbers. We can subtract any number from any number, given that the minuend should be strictly greater than the subtrahend. That is, this is arithmetic. So I call this a general case arithmetic subtraction because we're in the world, in the universe of arithmetic. That is, we're dealing with all positive numbers, including the solutions. That is the difference in this part, are all positive numbers. So in arithmetic, where we live in the natural numbers, that is positive integers all in all, we have a Vedic method with the use of bar numbers to do subtraction in a general case in arithmetic. Okay, general case. So I'm going to show you that. This has already been given, okay, in a lot of references. I'm going to give you more later. So let's have here as an example. So we have 5, 8, 9, 8, 1, 3 minus 2, 5, 3, 9, 8, 7. So how do we do this? We do this by normal subtraction, and then we're going to see some techniques. 5 minus 2 is 3. 8 minus 5 is 3. 9 minus 3 is 6. But 8 minus 9 cannot be in conventional methods. In Vedic maths, in general case arithmetic subtraction, we're going to reverse that part. Instead of reading it as 8 minus 9, we're going to read it as 9 minus 8. So 9 minus 8 or 8 minus 9 in our naked eye, it's going to become 1. But since we reversed it, we're going to do a bar 1 in this part. Okay, 1 minus 8, imagine it as 8 minus 1, put a bar. 8 minus 1 is 7, bar, and then put a bar there. So 1 minus 8 is bar 7, and 3 minus 7 is also bar 4. And we have some bar numbers here, and we need to reconvert that into a normal ordinary number. So how do we do that? We're going to do it something like all from 9 to the last from 10. Okay, we're going to make use of the Nikalam Sutra still. So 3, 3, we're going to borrow 1 here, that becomes 5, and then all from 9 to the last from 10. So what will you add to 1 to make it 9, 8, What will you add to 7 to make it 9? 2. What will you add to 4 to make it 10? 6. And this is our answer. 3,035, 300,000 rather, 335,826. And that's our answer for this example 4. Okay, that's making use of general case arithmetic subtraction. Let's have one more example. So we have 827,309 minus 395,975. Okay, so how do we do that? We're going to do that using the general case arithmetic subtraction still. And let's have it. 8 minus 3 is 5. 2 minus 9 is bar 7. Okay. 7 minus 5 is 2. 3 minus 9 is bar 6. 0 minus 7 is, well, it's bar 7. And 9 minus 5 is 4. So, excuse me writing here. So we have 5, bar 7, 2, 6, bar 6, bar 7, and 4. So this is where the concept of number splitting comes in. Okay, so we're going to split the numbers into different parts. We're going to split it here and here. Okay, so we're going to make use still of the sutra, the Nikalam Sutra, the all from 9, the last from 10, in order for us to make this and convert this into a normal number. So this will give us, we're going to borrow 5, 1 from 5, that gives us 4. And then this is all from 10 because it's the last number with a bar, that gives us 3. Okay, and then we have here this 2. This is another batch of a number, another group of numbers. So you're going to subtract 1 from there. So that becomes 1. And then what we have here is bar numbers. We're going to convert them into normal numbers. So what we're going to have is all from 9 to the last from 10. This is not the last number, so that this should be from 9. So this gives us 3. Okay, because you need 3 to 6 to make it 9. And then 7, we're going to make it 3. And then that's another group. And then we have 4. So therefore, our answer here is 431,334. And that's our answer for example 5. Okay, hopefully you're getting the hang of it. Let's have one more example for arithmetic subtraction. So we have 914,205. Let's get it straight away. 778 minus 816. What will be the answer? 9 minus 7 is 2. 1 minus 7 is bar 6. 4 minus 8 is bar 4. 2 minus 8 is bar 6. 0 minus 1 is bar 1. And 5 minus 6 is bar 1. So let's get the answer. We don't need the number splitting here. We just answer it straight away. So what we have is deduct 1 from 2. That's going to give us 1. All from 9 to the last from 10. Since it's one batch of bar numbers, this becomes 3. This becomes 5. This becomes 3. This becomes 8. And this becomes 9. So the answer is 135,389. That's our answer for example 6. Now we're done with general case arithmetic subtraction. This is how we do it. Okay, notice all our solutions are positive numbers. Okay, and it's due time for us to enter the domain of general case integer subtraction. So from the examples that is shown above in the general case arithmetic subtraction, one may ask and ponder, what if the subtrahend is greater than the minuend? I mean, it happens, right? So certainly the difference will be negative. That is, we're going to expect a negative integer there. That is z minus a negative integer. Now, what we'll do is extend this concept of general case arithmetic subtraction into general case integer subtraction. That is, we're waiting we're expecting a number or a solution, a difference that is negative, or that is an integer. Okay, a negative integer. So using the sutra, the same sutra, Nadikalam Navatkaram Dasata, you're all from and the last from 10. And this time we're going to use the transpose and apply sutra here, the Parvatya Yovaryet. and we will be ready to demonstrate, okay, the general case integer subtraction. How do we do this? Let's get into it. So for instance, we have 14,759 minus 98,531. Clearly, the subtrahend is greater than the minuend. Okay, the subtrahend is greater than the minuend. So what we're going to do first is we're going to transpose and apply this. Okay, transpose. Transpose first the subtrahend, make it the minuend, 98,531. And then 14, this minuend, this our minuend will become the subtrahend, 14,759. And then we apply the Nikalam Sutra. That's where the transpose and apply comes in here. So what we're going to do, this becomes 8, this becomes 4, this becomes bar 2, this becomes bar 2 still, this becomes bar 8. Okay, apply the sutra, or convert it rather, convert it into into an ordinary number. Apply the Nikalam Sutra. We have 8, 3. This becomes what? 7, 7. Last from 10, 2. And this is our answer, 83,772. But there's more. Okay, we need to apply and put a negative sign in this part. Okay, we need to put a negative sign in this part. That will be the last part of the process. Again, whenever we're subtracting, we're in the subtrahend is greater than the minuend, we flip them, we transpose them, we apply the Nikalam Sutra, and then when we get to the ordinary number, we insert a negative sign out there, and then that will be our final answer for that. And this is the main thing of this presentation. Okay, hopefully you got it. Let's have 2 more examples. So say we have 1,958,042 minus 9,899,529. So what we're going to do is we're going to transpose this. We're going to transfer this minuend down to the subtrahend this time. This becomes 1,958,042. And then we apply the subtraction. So we have 9 minus 1 is 8. 8 minus 9 is bar 1. 9 minus 5 is 4. 9 minus 8 is 1. 5 minus 0 is 5. 2 minus 4 is bar 2. And 9 minus 2 is 7. We may use some number splitting here, but if you know the concept, we may put the number splitting under the rug, and it can give us 7 rather. 7. This is the last number. This should be 9. 7, 9, 4, 1. This becomes 4. We're going to deduct 1 from it, and this becomes 8, and this becomes 7. Okay, so we have 7,941,487, and insert a negative sign out there, and this will be our answer. Okay, that will be our answer. Last example, let's have 2,788,137 minus 6,510,819. So we're going to transpose it first. So we're going to put the minuend first. So we have 6,510,819 minus 2,788. Sorry, this is a 0. 137. So let's subtract. Let's apply the Nikalam Sutra, and we have 6 minus 2 is 4. 5 minus 7 is bar 2. 1 minus 8 is bar 7. 0 minus 8 is bar 8. 8 minus 1 is 7. 1 minus 3 is bar 2. 9 minus 7 is simply 2. So let's convert it, apply the sutra here. So we have 3, all from 9 and the last from 10. So we have 7, 2, 2. Okay, number splitting. Imagine a number splitting in this portion here. So we have 6, 8, 2. And don't forget to input the negative sign out there. So what we have is negative 3,722,682. Okay, and that's our general case integer subtraction, um, all in all. Okay, now what we're going to do then is we're going to provide a proof for this. Okay, so the proof of this, why this works, why this general case integer subtraction works. So let's provide a proof. Okay, let's make it mathematical rigorously. So we will call S to be the solution or the difference, A be the minuend, and B be the subtrahend. The other parts of the paper, the earlier parts, I will not provide a proof of that. The proof is really shown from the book of Tirthaji himself. So I'm going to only prove the integer subtraction here. So if your subtrahend is strictly greater than your minuend. So what we're going to do by commutativity, we will have this. We have S is equal to minuend minus subtrahend, the normal. Commutative property, we can have it as negative B plus A. That is, we say that our solution is equal to negative B plus A. What we'll do then is we're going to multiply the whole equation by -1. So we have something like this. So from this equation here, we're going to multiply this by -1. Okay, so what we have is negative S minus negative quantity negative B plus A. Distribute the minus sign, so we have minus minus B plus minus A. So minus minus B will become positive B minus A. That is, we say that your difference is negative S. Your answer is negative. It's equal to B minus A. So hence here we can see that negative S equals B minus A. That is, we can deduct the subtrahend B if it's greater than A by the minuend A, provided that we flip the sign of the solution or the difference S. And that ends our proof. Okay, so meaning given that it's normally it's A minus B from this argument here, and that's the normal way we subtract, right? Minuend minus subtrahend. But the moment that when the minuend, the subtrahend rather, is greater than minuend, we flip them, provided that in the last part we put a negative sign on the solution. And this is where the sutra transpose and apply was used, actually. Okay, and that's the end of the proof. So summary, we see here that we can now subtract any number from any number, okay, with any type of solution, let it be positive or negative, the solution is. So formally, we call or we state the general cases of subtraction in Vedic maths. So we have two cases. We will let S be the difference, A be the minuend, and B the subtrahend. And case one, if your minuend is greater than your subtrahend, so your S is equal to A minus B, which is in the natural numbers. Hence, we call it general case arithmetic subtraction. Case two will be if your subtrahend is greater than your minuend, then it's equal to negative S. Your difference will be negative. It's equal to B minus A, to your subtrahend minus minuend. And your answer is inside the integers, because you may have the answer which is negative. So therefore, we call this general case integer subtraction. Okay, and hence the summary of this paper. So some conclusions. We say that Vedic maths is coherent and holistic. Hence, we can see here that subtraction can now be done in general case, which pupils can now see the operation in a totally new perspective, seeing it as not as rigid as it is, as we conventionally know it is. Hoping that that this Vedic method of subtraction can reach our primary and middle schools, so that pupils can also develop a holistic approach in mathematics. Okay, hopefully sooner than later. Okay, especially in math. As a Vedic maths advocate, this is one step at a time. Even though it cannot reach that soon, but it's a one step. That's why we do research. That's the main purpose of our research, in order for us to share. Okay, and the purpose of this conference is for us to share it. And I see this as one very important thing. So that's the end of it. I'm going to show you then the references. These are my references of my paper. And I want to acknowledge Kenneth Williams of the Vedic Mathematics Academy for his help. That is in the enlightenment of the use of number splitting in my paper. And also thank you, James Glover and Suwari Dave, for having me here in this online conference. I'm very much grateful to be part of this. So that's the end of it. Thank you very much. You can reach me through these links. I'm in LinkedIn. I'm in Facebook. I have Currently, I have a YouTube channel. Hope you subscribe there. I also do videos in Vedic math, and you can see my previous webinars there. I uploaded there, and then you can contact me anytime if you have some questions and clarifications. So thank you very much.